welcome back. It's Mrs. Muller again. Today we're going to use properties of logarithms in a little bit more detail. So I'm not going to ask you to turn in your homework from yesterday. That was more practice. We'll go over some homework problems a little bit, and then I'd like to make sure that you picked up a stamp sheet yesterday. So make sure you do that. We're going to do our lesson, and then I'm going to give you lots of homework time today. So let's begin. Just like yesterday, logarithms are exponents. We use logarithms when we're trying to solve exponents. Yesterday we talked about the power to a power property. Let's see if I can grab this guy a little bit and bring him down here. Okay, so we talked about the fact that since log b to the x is an exponent, when we take that exponent and raise it to a power of n, it's like saying we're multiplying the power. We'll pretend like this power is the same thing as this m right here. So when you raise an exponent to an exponent, so this is an exponent to the exponent, you're actually multiplying the two exponents. So that's what we're doing here. We're multiplying this exponent by this exponent. So whenever you see a power to a power, you can bring it out in front and say, I'm going to multiply it. All right, the product property. So I have two logs, and they're being added. Yesterday, we did it in reverse. Yesterday, we saw that m and n were being multiplied, and so we knew that we could apply the product property, and we could actually split them up as two logs with an addition sign. So now today we're going to kind of do the opposite. We're going to see the addition sign and say, oh, guess what? I can actually multiply m and n under the same log. And also the quotient property. So if you see two logs that are being subtracted, the key is, as long as they have the same base, in this case since there's no base, we know it's automatically base 10. So as long as they both have the same bases, you can turn them into a quotient with the same base. Alright, so that's a recap of yesterday. Let's look at your homework from yesterday. So the 50, we just changed it to 25, let's see, log base A, 25 times 2, which made log A 5 squared, plus, using that product property, plus log A to the 2. That 2 comes out in front, and we just call it, let's see, do equals, 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 2 log A5, and a log A5 is actually P. So 2 P's plus a log A to the 2, that's here, that's an R, so 2P plus R. That was number 1. Number 2 is 3/10, so I'm going to write it like 3/10. I'm having a hard time like right in this middle section. So let's do this. There we go. That's better. So equals log A to the 3. I'm going to write 10, 3/10 as 2 times 5. Because I already know I have a 2 and a 5 up here in my expression. So now I have log A log A to the 3 minus log A to the 2 times 5. I'm going to take this part, this portion right here, and I'm going to use the product property for that one. So we have, again, it's not going to let me go down like this. There we go. So now I have log A to the 3. What was A to the 3? Oops. A to the 3 is Q. So if a to the 3 is q, that's going to turn into a q minus log a to the 2 times 5, which is, oh, so frustrating. Let's do it down here. Keep it below there. There we go. It's so weird. Like, if I go up a little bit on my screen, I can't go past that point for some reason, because I'm doing this at home. Okay, so log a to the 2 plus log a to the 5. So that's that piece right there in blue. And then if I go ahead and let's cover this up. So now I have q minus log a to the 2 is actually r, and log a to the 5 is actually p. So that's kind of what we did yesterday. All right, let's take it the next step. So students will be able to use properties of logarithms to simplify and evaluate expressions. Same exact thing as yesterday, only we're just going to step it up a notch. Okay, so we're going to use order of operations, just like you've known order of operations thus far, except I call it gamma, and I like gamma because gamma includes grouping symbols rather than PEMDAS, which is parentheses, exponents. Grouping symbols I like because grouping symbols includes a division bar. That's included in a grouping symbol. So it's grouping symbols, exponents, multiplication slash division, and addition and subtraction. So we'll keep that graphic up there as we're doing these problems. So the first thing you need to do is decide what properties are appropriate. Power property, product property. You should have these written on your stamp sheet yesterday, and the quotient property. So we can use these properties forwards and backwards. Then we need to consider our order of operations and then simplify. So let's look at this first one. It says log base 7(3) plus 4 log base 7y minus 3 log base 7x's. So let's look at our order of operations. Well, before deciding what properties are appropriate, I know I'm going to need the power property because of this 4 and this 3. So that's going to require the power property. I know I'm going to need the quotient property because of the subtraction sign, and I see an addition sign. So we're going to need all 3 of these properties. We just have to decide which one we're going to do first. So let's start with our order of operations. Let's start with grouping symbols. Do you see any parentheses? I don't either. So we're done with our grouping symbols. Let's see. No grouping symbols. Let's look at exponents. We have a couple exponents. Well, logarithms are exponents, but are those logarithms being raised to powers? And we have 2 of them. We have a 4. That can be put as this exponent. And we have a 3. That can be put here, because it tells me to express it as a single logarithm. So like what we did yesterday is we kind of expanded a logarithm. Now we're going to try and unexpand the logarithm with using as many properties as we can. All right, so I'm going to go ahead and rewrite this. So I've got equals log base 7(3) plus log base 7y to the 4th minus log base 7x cubed, where the 4 and the 3 were originally multiplication out in front. Oops, that should be 4. I'm just messing it all up. There, better. Alrighty. So our exponents are done. let's keep going. So multiplication and division, I don't see any. This is a subtraction sign. So let's go to addition and subtraction. We're going to work from left to right. These two right here, always working left to right, just like when we read. All right. So I'm going to use the power property first, the product property, and I'm going to turn these two logarithms right here into one single logarithm. So that would be log base 7 to the 3 times y to the 4th minus log base 7 to the x cubed. Okay, so on my next step I'm going to go ahead and simplify this, but now I look at this and I say, okay, now I've got a subtraction sign. That's the last thing I've got. So I'm going to turn these two logs into a single log. Bring it up just a little bit. So I have equals log base 7. Now I'm going to make a quotient. I've got 3y to the 4th, and we're going to divide that by x cubed. And there's my single logarithm. Let's try another one. Why don't we see if you guys can try this one? So hopefully you paused the video and tried that one. Let's do it. So let's do log base 2 to the 10 plus 3 log base 2 to the x. We're in luck. We've got common bases here, so we can go ahead and use our properties. I'm going to start with grouping symbols. There aren't any. Then we've got exponents. We have one exponent. It's right out here in front of this log. It needs to come back up here in front of that x. So let's write an equivalent expression. So log base 2 to the 10 plus log base 2 to the x, but now it's going to be cubed. Okay, so no multiplication and division, so now we just need to go to addition and subtraction. So I'm going to treat this logarithm, I'm going to use my product property. It's got an addition sign, so we're going to turn it into one single logarithm with a multiplication sign. So equals 1 log base 2, 10 times x cubed, which can just be written. Let me just move this up and I'll write underneath it, which can be written, log base 2, 10 x cubed. Perfect. Let's try another one. All right. This time we've got grouping symbols. I think you guys can do this one, because if you think you can do it, then go ahead and pause the recording. Okay. So let me look at my grouping symbols first. I'm going to take these two natural logs and turn them into one natural log. Since it's a subtraction sign, I know I'm going to make it a quotient. So let's just leave the 3. And I'm going to turn this into 1. I'm not even going to need the grouping symbol anymore. Let's just take it off. So I've got, and change my color so we don't get confused with that 3. It's being multiplied by the quantity of this new natural log. So natural log, the 3 is going to be in the numerator, the x is going to be in the denominator. Plus, let's do the same thing with this one. It's going to be a single natural log. It's a quotient property. X is in the numerator, 9 is in the denominator. All right, so I'm done with my grouping symbols. Now we're going to move on to exponents. I've got an exponent here. This exponent is going to come right here. This whole thing is being cubed. The 3 is being cubed and the x is being cubed. So I can rewrite this. I'm going to write it down here because I know that it won't mess up on me down here. So I've got natural log I said it wasn't going to mess up on me, but it is. So let's move it as far up as I can, and I'll write above it. Equals natural log, we'll say 3 cubed over x cubed plus natural log x over 9. So we're done with all of our exponents. Multiplication and division, adding and subtracting. Let's use that product property. So I'm going to take these 2 natural logs, these 2 natural logs, and turn them into one single natural log. One quick second. There we go. Okay, so natural log. Three cubed is 27 over x cubed times x divided by 9. Got a few things I can do in here. 9 and 27 makes me a 3. And if I take this x, I only have 2 left over. So I just have to rewrite after I simplified. Equals natural log 3 over x squared. Done. Okay, I'm not going to go through all these. It looks like we're at 18 minutes now in the recording. I'd rather you guys have some extra time to do plenty of this in class. I want you to be able to do all your homework in class and then possibly get back to working on that cumulative together. So let's just talk through this one. So the 1/2 would end up on top of this z, right? Which you could technically think of as z to the 1/2 or the square root of z. Look at it both ways. Let's see, we're going to have to do the addition before the subtraction. So you'd have to then grab these 2 logs and join them together. Oh, look, we missed one. That 3 needs to come out here with the y. That would take care of all of our exponents. Change my color here. Actually, we should. All of this should have been in this color. There we go. All right. Then here, I would take this one here and use the product property. And then after I'm done with that, I would take that single log. Let's just do it. I'm already halfway there. I'm going to write it down here because it'll be easier for me to write. Okay, so now I have log of an x times y cubed minus log, I'm just going to write like this, square root. I think on my Yikes. I think on my answer key it is the square root. And now, one more time. That's right, one more logarithm using the quotient property. So I'm going to have log quotient xy cubed over square root of z. All right, so you should, all these are homework problems. So if you'd like to go back to this first one and write number 2 down, you could do that. Then you could write number 4 down. Then number 6. And number 11. So we did, what is that, 4 of your homework problems? There's another one that's totally doable. These are actually quantities. There's nothing I can do with that, right? It's just part of this natural log. The only thing I can do with this is make that a power here, and this a power here, and then I can use the quotient property. So the sub has an answer key for all of the homework. And, oh, let's do this. One more. Evaluate. All right, so I'm going to use everything I know to evaluate this. Evaluate means basically simplify it. All right, so I know I've got a 3. This 27, I noticed 27 has a base of 3. So let's rewrite that. Log 3 to the 3 cubed. 3 cubed is 27. Same thing with this one. Minus log 3, 81 is actually 3 to the 4th. Let's use our exponent rules. My exponent rules tell me that I could take this 3 and actually put it out in front, and this 4 and put it out in front, and I will be left with 3 times log 3 to the 3 minus 4 times log 3 to the 3. Well, you should notice something. What is log 3 to the 3? Let's see. Log 3 to the 3 equals what? 3 to the x, right? If this is the base and this is the exponent, 3 to the exponent equals, I'm changing it into exponential form. Well, 3 to the what makes 3? 3 to the 1. So this is actually 1. This is 1. And this is 1. So I really only have 3. Use this up just a little bit more. I really only have 3 minus 4, which is negative 1. So let's evaluate. Give another one here. You could evaluate this by changing 25 into a 5. Right? This could be a 5 squared. And that 5 squared could be turned into log 5 to the 5 minus 2. And then you should notice that log 5 to the 5 is just 1. So this whole expression right here, this part of it, is just negative 2. I'll let you do this one. This one's very similar. Okay, that's it. So one more lesson tomorrow. Miss Liz is going to deliver that lesson, and then we'll see you guys back on Thursday. Remember, get your homework done. I'm not going to give you a free ticket on the homework tomorrow. You're going to have to turn it in. It's going to get checked. Okay? So hope you guys are doing good. Bye.